Hello everyone, welcome to my YouTube channel Physics Numericals. Learn to solve numericals step by step in an easy way. Today let's solve a numerical of chapter Newton's laws of motion based on the concept connected motion. So let's start. Two masses of 10 kg and 6 kg connected at the two ends of an inextensible string pass over a smooth frictionless pulley. Calculate acceleration of the system and tension in the string. So इस क्वेश्चन में दो masses है 10 kg और 6 kg. Suppose m1 is 10 kg and m2 second mass is equal to 6 kg. Clearly m1 mass is greater than m2 mass. So if we draw pulley, it will be like this. Mass m, lighter mass will be at this place m2 and heavier mass will be like this m1. Now there will be tension in the string T. It is a frictionless pulley, so the tension in the string will be same for both the masses. Also the heavier mass will move downwards and the lighter mass will move upwards. Let the common acceleration of both the masses be A. Now, for calculating acceleration of the system and the tension in the string, we will find out the equation of motion for both the masses m1 and m2. So, for mass m1, which is of 10 kg, we can see in this figure that the forces which are acting on this mass m1 are downward force, which is weight m1g is acting downward, it is the downward force, and the tension T is acting in the upward direction. Also there is an acceleration A, so net downward force will be equal to m1a. So if we write the equation of motion for mass m1, it will be m1a, which is the net downward force for mass m1, that will be equal to weight m1g, which is in the downward direction, minus tension T, which is in the upward direction. So this is first equation. Second, for mass m2, which is of 6 kg, we can see there is downward force, which is the weight m2g. Upward force is tension T in the upward direction, and net upward force will be equal to m1a. So if we write the equation of motion for mass m2, it will be equation of motion for mass m2, it will be net upward force is m1a, sorry m2a, this is mass m2, so m2a, which is equal to tension T in the upward direction minus weight equal to m2g, which is in the downward direction. So this way we have two equations. Now we will solve these two equations and we will find acceleration and tension. First of all, if we add these two equations, we will get m1 adding equation 1 and 2. m1a plus m2a is equal to m1g minus t plus t minus m2g. It will get cut. So a m1 plus m2 is equal to m1 minus m2 g, which implies A is equal to m1 minus m2 divided m1 plus m2 into g. We will put the values of mass m1 and m2 to calculate the acceleration A. So m1 is 10 kg. So 10 minus 6 by 10 plus 6 multiply. If we take g equal to 9.8, then solving this we will get 4 by 16 into 9.8. So finally acceleration of this system will be equal to 2.45 meter per second square. Now let's calculate tension. Again we will use these two equations for calculating tension in the string. First equation is m1a is equal to m1g minus t, and second equation is m2 second equation is m2a is equal to t minus m2g. m2a is equal to t minus m2g. If we divide these two equations, equation 1 and 2, dividing equation 1 by 2, m1a by m2a is equal to m1g minus t divided t minus m2g. These two will get cut. So we will have m1t minus m1 m2g is equal to m1 m2g minus m2t. So m1t plus m2t is equal to m1 m2g plus m1 m2g. Solving this, we will get tension T is equal to m1 to m1 m2 divided m1 plus m2 into g. So we will put the values of the masses m1, m2 and g. So we will have 2 into 10 into 6 into 9.8 divided 10 plus 6. So 10 multiply 10, 2 multiply 10 multiply 6 multiply 9.8 by 16, and so when you will solve it, it will be equal to 73.5 Newton. So this way we can calculate acceleration and tension in the string. So in these type of questions in which we have connected motions of two masses, we find equations of motion for the two masses separately, and we solve it to find the acceleration and tension. Thank you.